Hey, welcome back. It's Sullivan here, and we're talking today about Module 4, Topic 1. We're on our last lesson. It's called Farmer's Tan, and let's be honest, that is very unique, but we're going to be talking about the tangent function. So a few things about the tangent function that you need to know. Number one, tangent of an angle is equal to opposite side over adjacent. So to recap, this is how I remember all of them. I say it so, ka, toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, you'll also learn that tangent is sine over cosine. And if you think about it, the reason is when we have our angles in our unit circle, the opposite side is always our sine because it's always going up. Our adjacent side is always our cosine, our x value, right? So this is also our y over x. It's a lot like slope when we do a tangent graph. So a little unorthodox. I want you to go to page 819. All right, remember on 819, I prefer you write it cosine and sine and then tangent. But the thing here is, what is the sign of all the tangents in here? Well, when I divide a positive, a sine divided by a positive cosine, my tangent is going to be positive. Okay? Over here, when I switch these around, so this is cosine, sine, because cosine is x, sine is y. So my tangent is sine over cosine. So when I divide a positive number by a negative number, my tangent in here is always going to be negative. So in quadrant 2, I'm always going to have a negative. In quadrant 1, I'm always going to have a positive. Well, let's look down here. Quadrant 3. So again, cosine, sine, they're both negative. So tangent is a negative divided by a negative, which is a positive. So every value in the third quadrant of our tangents should be positive. All right, and last but not least, cosine, sine. So cosine's positive here and sine's negative. So tangent is going to be negative over positive. That will be a negative. All right, so let's find some of these. All right, first one here, I have a 30-degree angle. I'm going to show you two ways to do it. I told you already the tangent was sine over cosine. So the sine is a y value. So this is equal to 1/2 over radical 3 over 2. Now, that is one horrendous looking, terrible, absolutely disgusting fraction. This is a terrible way to do things. But if you remember your triangle, which honestly, if you can't remember anything, you need to remember these triangles and how to find sine, cosine, and tangent from them. So tangent is opposite 1 over adjacent radical 3. And now you need to remember that I don't like radicals in the denominator, so I'm going to multiply this by radical 3 over radical 3. And I get, in the end, radical 3 over 3. And it's positive because we're in the first quadrant. Let's do this one here. This is a 60, right? Same thing. 60, 30. So this is 1. This is radical 3, and this is 2. So sine is or tangent is opposite over adjacent. The opposite side of 60 is radical 3 over 1. So this is radical 3. Amazing. All right, let's find this one. Tangent of 45. Tangent of 45. Well, we know that right now this is going to be a 45, 45, 90 triangle. And about 45, 45, 90 is 1, 1 radical 2. So here's my angle. Opposite is 1 over adjacent 1. So my tangent of 45 is 1. There you have it. All right, so let's talk about quadrant 2. First thing I know, all my answers are going to be negative. And the reason, I'm going to the left, which is a negative, but I'm going up, which is a positive. So a positive divided by a negative is a negative. Now, if you remember, these values match, right? So the tangent of 150 is going to be the same as the tangent of 30, but the signs are going to be different. So the tangent of 30 is radical 3 over 3. So the tangent of 150 is radical 3 over 3, but it's in the second quadrant, so it's negative. All right, let's try the next one. The tangent of 3 pi over 4 is the same as pi over 4. It's 1 over here. That means it's 1 over here, but the sign is negative. Don't believe me? Let's draw the triangle. Here's my triangle, right? Here's my angle right here. This is to the left one. This is up one. Opposite over adjacent. 1 over negative 1 is negative 1. Let's do this one. Tangent of 120 is going to be the same as the tangent of 60. Radical 3. So this is going to be a radical 3, but it's in the second quadrant, so it's negative. All right, I'm going to help you with one more. These are going to match, right? This is a 30-degree angle. So it's opposite over adjacent is going to be the same, except for I have a negative and a negative, which makes it a positive. So therefore, instead of being negative radical 3 over 3, it's going to be positive radical 3 over 3. All the values here are going to be positive. So right now, I want you to pause the video and complete all the third quadrant and all the fourth quadrant. And remember, all the tangent values in the fourth quadrant are going to be negative. So go ahead, take a second, pause the video, and fill those out. All right, so as I said, these values match up. So this is going to be all positive. So this is going to be radical 3 over 3, 1, and radical 3. This is going to be negative radical 3, negative 1, and negative radical 3 over 3. All right, because these are all negative. Now I want you to see a few things here. We didn't talk about tangent of 0. This is easy to think about in terms of sine over cosine. 0 over 1 is 0. Tangent of pi over 2, sine over cosine. Am I allowed to divide by 0? No, that's undefined. Over here I have sine over cosine, so that again is 0, so the tangent of pi is 0. And down here, this is negative 1 divided by 0, so I can't divide by 0, so that again is undefined. Now one thing I'd like to talk about is, remember we go counterclockwise, right? So what I want you to notice is the values here from 0 to pi, and then again from pi to 2 pi, they repeat. Radical 3 over 3, radical 3 over 3, 1, 1, radical 3, undefined, undefined, negative radical 3. It's the same thing, right? It doesn't take the whole circle to repeat. Its one period is not the whole 2 pi. In fact, its period is half of that, or just pi, because these values are exactly the same as these values. All right? So on the next page, which actually is back to page 810, I want you to go to page 810, pause the video, write these values down, and then also write down what they're equal to. Go look at your unit circle and see what they're equal to. And I want you to notice they match up very nicely. All right, go ahead. All right, now one thing I want you to understand is the book's talking about a slope, and I'm kind of skipping around. I understand. I'm sorry, but it is the slope, right? We are finding slope of a line when we do rise over run, sine over cosine, y over x. That's what we're doing. So check this out. The slope of this unit circle, what's happening as it gets, right? As it gets higher, it goes from less than 1 to equal to 1 to above 1. It gets really big, right? In fact, this slope, honestly, this slope right here is like 10 over 1. Like it's massively, it gets almost infinitely large going upwards, right? A vertical line almost. So the slope gets higher and higher as I go. So that means the tangent as I go towards 90 degrees gets higher and higher. And then as I go away from 90 degrees, the slope gets lower, lower back to 1, less than 1, all the way till it gets to flat slope of 0. So now let's go over here. And I talked about this. We have our points, so let's plot these points, and these are already plotted, but let's do it anyway. All right, so tangent of 0 is 0. Pi over 4 is 1. Pi over 2 is undefined. Whenever it's undefined, we have no value, but we have an asymptote there, so we're going to put the asymptote there. Now check this out. Between pi over 4 and pi over 2, that's what I was talking about here. The slope, as I get higher and higher and higher, gets larger and larger and larger. So as I fill this graph in, I know that as I approach that, it's going to get higher and higher and higher, right? Likewise, when I'm coming off of that slope, when I come back from here, I have a really big slope, but it's a negative, like negative 10. And these are negative slopes because it's going down. So my tangents are negative, really massively negative numbers until I get back to 3 pi over 4 is negative 1. Pi is 0. Boom, just like that. Now, as I told you, this is one full cycle. Because once I get back here, I'm at the exact same point I started, and I'm going to go and do the exact same thing. See, look, pi over 4, 5 pi, the same exact thing. 5 pi over 4 is 1. 3 pi over 2, asymptote. So I'm going to draw my asymptote. So now I know this is coming in here, and as it gets here, it's going higher and higher and higher, infinitely, right? It's going to repeat itself. 7 pi over 4 is at negative 1. 7 pi over 4 is at negative 1. And I know that at 2 pi, it's going to be back at 0. So I know it looks like this. I could come over here and complete this as well. I know that at negative pi over 4, it's going to be at negative 1. It's coming down, coming down, coming down, much like that. All right, and I would have my asymptote. Okay? Now let's look at this graph. Look at this, the period. How long does it take to repeat itself? Look at the asymptotes. How long are those asymptotes? Well, this asymptote is from negative pi over 2 to pi over 2. That is 1 pi. So again, on the graph, the period is pi. Tangent, period, is pi. Massively important. Sine, cosine, the basic ones, the period is 2 pi. Tangent, the period is pi. It repeats itself over and over and over again. All right? Let's talk about something else on this graph that's really cool. All right? I'm just going to erase everything for a second. I know, like you must hate me. All right? So, this is like super slow to grow. All right. Here's how I graph them. You ready? Here's how I graph it. I'm going to do it in blue. Hate blue. Going to do it anyway. I know the tangent of 0 is 0. So I start at 0. I know my period. I know my period is pi. I know that means half of my period is this way is going to be an asymptote. So half of pi is pi over 2. So I know that. Boom. I know that half of between 0 and pi over 2, half of that is pi over 4, and it goes up 1. Boom. That's my amplitude right there. That's my amplitude. If I had 2 tangent of theta, I would go up 2, but it's always half. Halfway here, I'm going to go down 1, my amplitude. And I'm always approaching those asymptotes. So I'm going to do it again. I'm going to go from pi over 2, pi units away, boom. Halfway, my 0. Halfway between there, my amplitude's up. Halfway between here, my amplitude is down. And I have my graph. Boom, halfway over here, pi units, halfway I'm at 0, halfway I'm up at 1, halfway I'm down at 1. Boom, over and over again. All right? All right, I am on page 812. Sorry, I know I'm skipping around. So again, here's our tangent function. Remember, tangent of 0 is 0. Half of pi over, I go up. Half of pi over, I have my asymptote. From negative pi to pi over 2, or pi over 2, negative pi over 2 to pi over 2, that's a period of 1. My period is 1 for tangent. All right? Question number 1, how can I write tangent in terms of sine and cosine? We've already talked about this. Tangent of theta is sine of theta over cosine of theta. In which quadrants are they positive or negative? We talked about this. This is what I love this. So let's see. Cosine is positive, sine is positive, right and up. That means tangent is positive. Positive divided by positive. Over here I go left, so cosine is negative. Sine is positive because I go up. So tangent is positive divided by negative, negative. So in quadrant 1, positive. Quadrant 2, negative. Remember, we talked about it. The period is pi. So pi, that means it's going to repeat. That means from here, this is going to be positive. This is going to be negative because it's the same. When I go from here to here, it's the same as when I go from here to here. Its only period is pi units long. What do you know about rational functions to describe discontinuity? Well, discontinuities are those asymptotes. Right? What do we have in asymptote? Whenever the bottom equals 0, right? So tangent is sine over cosine. So for this, all we have to know is whenever cosine is 0, we have an asymptote, a discontinuity. Okay? Let's take a look. Anytime our cosine is 0, cosine is 0 here, pi over 2, here, 3 pi over 2. Pi over 2, 3 pi over 2, 5 pi over 2, negative 1 pi over 2, negative 3 pi over 2, negative 5. 1, 3, 5, odd numbers, which leads us to the next question, number 4. What is the value of tangent n pi for any odd? So any odd value divided by 2, any one of those, we know it's going to be undefined. That is going to have a situation where cosine of theta equals 0. That's exactly what's going to happen. Therefore, it's going to be undefined. All right, let's go to the next one. Transformations, too easy. I'm going to start you out here. I know that a tangent of 0 is 0. I know that half of my period is to the left of that. I know that half of my period is to the right of that. All right? Now, what does the negative do? It flips upside down, right? So typically I go halfway and I go up. Well, that means I'm going to flip it from up to down. Halfway, I'm going to go down 1 unit. Typically, when I go to the left, I go down, so I'm going to go up. So halfway, I'm going to go up 1 unit. Boom. And then repeat every pi units because it's periodic. Halfway, up 1, halfway, down 1. Booyah! Same thing. Do I really need to do it over here? I'm not going to do it perfectly. Sorry. Ooh, that was nasty. All right, same thing over here. We can do it over here. All right, I want you to try this one. Think about what that negative on the inside means. I'll start you off. I'm going to start you off with this. Ooh, there's some asymptotes here and here. There's some asymptotes here. Oh, period. Pi units away. Pi units away, yeah. Pi units away, yeah. All right. We also know that 0, pi, 0, 2 pi, 0, negative pi, 0. All right. Negative 2 pi, 0. Oh, man. I really screwed these up. They're not asymptotes there. Too close, too close. Sorry. All right, so pause video. I want you to graph that one. Go. All right, so again, the negative x is a horizontal reflection, right? So my left point becomes my right point. Right goes left, whatever. What you'll notice is it's the exact same graph as up here because normally I have a point here and it reflects over to here. So every point that was over here reflected over there. And we have a graph that is very similar to this. So you could say now that negative tangent of x is the same as tangent of negative x. Interesting. But this leads us to all transformations work out, right? So this is 1/2. That changes our period. We know our period for tangent is, the period is pi over b. That's how we find it. So now this is pi over 1/2 or 2 pi. So I'm looking for a period that is much wider. Let's look down here. Which one of these has a period that is much wider? Yeah, right here, right? So this has a period that is 1, 2. This period is 2 pi. So I now know that this is tangent of 1/2 x. Because again, this is a horizontal dilation. I know it looks like it should be shorter and skinnier, but it's not. In fact, what happens is it's much, much wider. All right, here, first thing I notice about this is it's up 1. So our midline, which is normally 0, is now going to be up 1. The other thing I noticed is that we have an amplitude. So instead of it going over like this, over 1, up 1, it's going to go over 1, up 1/20th. So it's going to be very, very flat. So let's take a look. Ooh, this one is very flat. And it goes up 1, up 1, very flat. So this is going to be 1/20th tangent theta plus 1. All right, let's look down here. This is a phase shift. So normally we start tangent of 0 is 0. So now we're going to shift it to the left, pi over 2 units. So that 0 now, instead of being at 0, 0, should be at pi over 2. Let's see which one of these does that. 0, 0, ah, here it is. It went to left. So now this is tangent of theta plus pi over 2 because it shifted left. All these transformations are the same from all the functions we've done all year. Well, this should be easy. This has got to be 2 tangent of x, but let's look at y. Normally, I start at 0. Halfway, I go up 1. Now, halfway I go up 1. Halfway now, I'm going up double that. So halfway, I go up 2. Check it out. Halfway, I go down 2. Same thing here. Halfway, I go up 2, down 2. All right? Everything is the same. All right. Page 821. There you have it. Your bookwork. Complete the unit circle on page 819. Ah, we already did that. Done. It should be complete. All right. Page 821, 822. Numbers 1 through 7. Hit that up right quick. All right. Make sure you're asking lots of questions. Get any help you need from us and from your teacher wherever you are. Lots of luck. See you next time.